It comes from the mature novel who wrote it by Jin Yong, and the Xuantie. It is a magic material, and it's a magic metal. Based on it, we can make a lot of magic weapons, such as Heaven Saber and Dragon Sword. And so I think our processor is much like the Xuantie, and it is also a magic material, and our customers can, based on our processor, to build their magical chips in their own business. So this is why the Xuantie comes from. Okay, let's get started. I think in these days, two words are mentioned lots of times, and one is AI and one is IoT. And put them together is AIoT. And in the AIoT area, I think most of everything is connected, and everything is became more and more intelligent. And the vision of our T-Head company is that we want to be the provider of the chip infrastructure of the AIoT area. And let's see what we've got. In the bottom, we can see we've got the RISC-V compatible processor, and we have a complete product line from the low power processor to the high performance processor, okay? And all these are baseline processors, and we will add some domain specific technology to the processors, and so they became the domain specific processor. And above the processor, it is the SoC platforms. It contains our IPs from our own, and also contains IP from our partners. And we are expecting more partners to join us. And above the SoC platform is the OS. We recommend the Ali OS, but also we supported many other OSs. All these three layers combined together to be the infrastructure of the edge side of our own. And as to the cloud side, we have Aliyun, and we can provide to our customer the huge computing power and provide the platform for them. And our customers can, based on our edge-to-device infrastructure, and add their unique technology to build their own competitive chip. So we think we believe our customers are all more experienced in their domain. So we do the common base job, and they do their unique and creative job. And together, we can win the business. Let's see our product line. The Xuantie 902 is our first RISC-V processor, and it's a tiny little core with a two-stage pipeline. And one feature of it is the hardware-enhanced security solution. And okay, here's the Xuantie 910. It is our flagship product, which we released it a few days ago in Shanghai. And it is an ultra-high-performance processor with the AI acceleration engine, and what's more, a new product is coming soon. In this soon, I really mean very soon, so stay tuned. Okay, and all these three processors are baseline processors, and each of them can develop to many kinds of domain-specific processors. Okay, let's get to the Xuantie 902. It is the ultra-low power architecture, and the ISA is RV32 EMC, and the RV32 IMC version is about to ready these days. And it has a two-stage in-order pipeline and support both machine and user mode. And it has a configurable hardware multiplier and some tightly coupled IP such as interrupt controller, timer, and one feature of the Xuantie 902 is that it has a configurable cache, because as we know, in the scenarios in Xuantie 902 is used, almost all instructions are contained in the flash, and the access time of the flash is quite long. So we add a cache to improve the instruction fetch efficiency. And also Xuantie 902 is very area efficiency. So, and as I said before, the most important feature of Xuantie 902 is that it had a hardware-enhanced security engine to help our customer to improve their security level of the system. Okay. Let's move to today's protagonist, and it is Xuantie 910. It is an ultra-high performance architecture processor. The ISA is RV64 GCV, and it is, of course, a multi-core processor, and it's class-based. And it is a 64-bit, 12-stage out-of-order pipeline. Xuantie 910 can decode 3 instructions and issue up to 8 instructions in one cycle. And one thing I must mention is that in the Xuantie 910, we first bring the dual issue out-of-order memory access system to the RISC-V processor. And furthermore, as we know, the 2 pain points of the high-performance processor, one is the instruction fetch efficiency, and one is the data memory accessing bandwidth. To address these issues, we adopt a hybrid branch processing technology and a multi-mode dynamic data prefetch technology. So, and what's more, Xuantie 910 is equipped with a vector engine for AI acceleration. So, based on these issues, these features, Xuantie can get a remarkable performance. As we can see, the core mark score is 7.1. And as we know, this is the first processor who achieved the core mark score above 7. And we can see a 40% in performance improvement compared to the leading products in the industry right now, compared to the RISC-V processor. Okay. And the Xuantie 910 is fully compatible with the RISC-V specification. As we said, the ISA is RV64 GCV, and the vector engine is based on the RV vector extension. And we all support all the machine mode, supervisor, and user mode. And the memory management and the interrupt controller are all standard. So, and besides these standard RISC-V technology, we also put some extended enhancement we call the RISC-V Turbo technology to Xuantie 910. We add more than 50 instructions to all these fields like computing, bit operation, memory accessing, and multi-core synchronization. And we also put some enhancement in the program model, such as in the field of memory management and cache TLB operation. I know these issues are being discussed in the task group these days, and we are willing to share our experience in these fields. And because of these features, this RISC-V Turbo technology, we can see that in the benchmark we tested, we have impressive performance improvement. And this is the overview of the overview of the pipeline of Xuantie 910. It is a 12-stage pipeline, out-of-order pipeline. And as to the ALU instruction, it is a 9-stage pipeline. And as to the memory access instruction or other complex arithmetic instructions, it has a longer stage of pipeline. And all these pipelines, we can divide into 2 parts. One is the front end, and one is the back end. The front end is responsible of instruction fetch, instruction package, instruction decoder, renaming, and issue. We can fetch up to 8 instructions, decode up to 3 instructions, and issue 8 instructions in each cycle. And when we go to the back end, we get an out-of-order memory access unit. And we also have a dedicated branch processing unit. As we know, branch instructions are very important when we go to the high-performance processor. And we also bring out-of-order to our vector pipelines to improve the performance. Let's get a detail of some of our pipeline units. The instruction fetch unit is in responsibility of the fetching the instructions and feeding it to the backend. So if we can't feed enough instruction to the monsters in the backend, the more execution unit we have, the more waste we created. So it is very important for the performance of the processor. And as we know, branch instruction are the key of the high-performance processor when we go to the instruction fetching. So we adopt a multi-mode branch prediction. We can make prediction with both branch branch direction, branch target, and return address, and indirect branch. So furthermore, the fetch bandwidth is 128 bits, and we can package up to 3 instructions in each cycle. And so it is a high bandwidth of instruction fetching. So when we go to the low power, we add some technology such as cache rate prediction and loop acceleration. So when we fetch the instructions, we can shut down most of the cache banks. And when we go to the loop programs, we can shut down all the cache banks to reduce the power. And as I mentioned, the dual issue out of order load store unit is the biggest feature of Xuantie 910 because it is the first processor to bring the dual issue out of order memory access system to the RISC-V RISC-V systems. It is the key. Is the key of the high performance of Xuantie 910, but it also brings a lot of difficulty and complexity to the design. So as we can see, in each cycle, we can issue one load instruction and one store instruction. And further, we split the store address and store data and to be 2 pipelines. So the store address can be issued and access the cache before the data is ready. And all the store and load instructions are executed very fast. And the load to use latency is 3 cycles. As I know, it is the top performance of the high performance processor these days. And we also support faster complete of the store instruction. So it only takes 1 cycle to execution. And when we go to big program, I think lots of cache misses are inevitable. So the data prefetch technology is very important. So we adopt a multi-mode and multi-channel data prefetch technology, and the data prefetch can both based on the virtual and the physical address. And the prefetch capacity can be configured. So we can, according to the behavior of the program, to configure the capacity of the prefetch. Okay. And the multi-core interconnection of the Xuantie 910 is very efficiency too. We adopt a decoupled processor interface to cut the critical path between all the cores. So each core can run at a very high frequency. And we adopt multi-coherence protocol and directory-based architecture. Furthermore, we add a Snoop filter so to reduce the communication congestion between these cores. So when one data is in the L2 cache, so we didn't need to snoop it to the other cores, the L1 cache of the other cores. And the L2 cache is configurable. We can configure up to 8 megabytes. And by the way, ECC is supported, surely. Xuantie 910 is equipped with a vector computing engine, and the vector engine is compatible with the RISC-V vector extension, and we base on the latest stable version of the V extension, and it supports all kinds of floating points and integer data types. And the operation width is configurable, and a typical operation width is 256 bit. And we also adopt 2 dual issue out of order pipeline to the vector computing to further improve the computing power of it. And within the 4 cores in the cluster, we can provide more than 300 G-flops of half precision computing power. So this is the physical implementation of the Xuantie 910. And as we can see, in the 12 nanometers process, we can push the frequency to 2.5 gigahertz. And we believe that when we go to the more advanced process, such as 7 nanometers, we can get a higher frequency, of course. So let's get a quick conclusion. And today, our Xuantie 910 is an ultra high performance superscalar processor. And as we know, it is the highest performance processor in the RISC-V today, and it is fully compatible with RISC-V specification. And we also add our RISC-V turbo technology to the Xuantie 910. And the biggest feature of Xuantie 910 is that we adopt the dual issue out-of-order memory subsystem to the processor. As I said, it is very complicated. So almost every core in the industry now, they use a single issue memory access unit, right? But we use the dual issue to further push the performance to another level. And we also equipped it with the AI vector acceleration engine. And the engine is based on the standard V extension. And one of the scenarios we expect the Xuantie 910 will use is the AI acceleration. So we surely adopt the vector engine. And now it's about time to see. Thank you for listening. All right, but there's still one more thing. Okay. Our Wujian 100 open platform. We open source this platform a few days before in Wuzhen in the World International Conference, and you can download it in the GitHub right now. And in this platform, it contains our open source processor, and it also contains many other critical IPs. And besides these hardware things, it contains all the software things such as OS, such as drivers and example testing suites. And you are very welcome to download it from the GitHub and to try it and to develop your own product based on our open source platforms. And we are very happy to contribute our experience in the industry, and we are do a lot of things to do the open source work. Okay, now, okay, this is the really time for me to say thank you for your listening. Thank you. Is there any questions?
So you have a dual issue memory pipe. It wasn't clear to me whether you could do 2 simultaneous reads or it was 1 read, 1 write, or even 2 writes.
Oh, it's 1 read, 1 write.
Okay, that's what I thought.
Probably in the next generation of our product, we will improve it.